Hello, my dear listeners, and welcome back to the Kapeel Gupta Career PodShow. And today, I want to imagine a student who is staring at a phone screen and thinking, this tiny device can click photos, scan faces, show maps, support video calls, and even help doctors. But have you ever wondered who helps make light behave so intelligently inside cameras, sensors, microscopes, lasers, satellites, medical imaging machines, and fiber optic systems? Very often, behind that magic stands an optical engineer. An optical engineer works with light, not in a poetic way, but in a highly scientific and deeply practical way. Edmund Optics describes this work as designing optical and optomechanical systems from imaging systems to laser optics across wavelengths from UV to IR. Creole at the University of Central Florida explains that optics and photonics power applications across healthcare, telecommunications, manufacturing, defense, security, entertainment, nanotechnology, and even space exploration. So, this is not some narrow lab only career, it's a future facing engineering path hiding inside the technologies young people use every single day. So, let us put this into a real life picture. Suppose a self driving car must see better. Suppose a surgeon needs sharper imaging. Suppose a satellite camera must detect tiny details from space. And suppose a telecom network must move huge amounts of data through optical fiber. In all these cases, somebody has to understand lenses, light paths, sensors, coatings, alignment, tolerances, waveguides, lasers, imaging, and signal quality. And that somebody may be an optical engineer. And if you're a student who loves physics but also wants to build real products, this career can feel like science fiction becoming a salary. Hi, I'm Kapeel Gupta, career coach, life mentor, and founder of Study Abroad Academy. I empower students, parents, and conscious professionals to design a fulfilling life and career by aligning their minds, values, and aspirations. And I do it with coaching, mindset work, and the game changing power of graphotherapy because students deserve more than just guidance, they deserve transformation. So, let's dive in. Now, let us talk about scope because passion is lovely, but students and parents also want to know, is there a future in this? Yes, there is, and it is stronger than many students realize. In India, optics and photonics are no longer side topics. IIT Delhi now has a dedicated optics and photonics center, and its academic focus includes ultra fast and quantum optics, nanophotonics, imaging, sensing, biophotonics, optical engineering, lasers, and guided wave optics. IIT Delhi also offers an interdisciplinary MTech in optoelectronics and optical communication, jointly run by Electrical Engineering and Physics. IIT Madras has active research in nanophotonics, integrated photonics, quantum optics, and a silicon photonics research center of excellence launched with Meetwise support to strengthen the future ecosystem of photonic integrated circuit manufacturing in India. IISc's research ecosystem also includes integrated optics, photonics, optical communication, sensing, and silicon photonic integrated circuits through SENSE and ECE. That tells us something very important. India is building serious capacity in optics, photonics, and optical engineering, not just teaching theory. And that means opportunities in India can come from telecom, semiconductor link network, photonic integrated circuits, defense and aerospace, imaging systems, sensor companies, medical devices, precision manufacturing, machine vision, AR, VR lasers in research labs. ZEUS, for example, shows roles and applications spanning medical technology, research microscopy, industrial quality, semiconductor manufacturing, photography, extended reality, and satellite optics. Edward Optics also shows how optical design sits inside imaging, laser systems, coatings, spectroscopy, and factory automation. So the field is not waiting only inside a physics department, it is spread across industries that are becoming more important every year. Abroad, the scope is even more mature. The University of Rochester Institute of Optics offers dedicated BS degrees in optics and optical engineering and notes that it has granted more than half of all optic degrees ever awarded in the United States. University of Arizona's Wyant College of Optical Sciences described itself as one of the premier institutions in optics and photonics worldwide. Creole at UCF says it's among the best optics programs globally and highlight works in laser engineering, medical imaging, augmented reality, semiconductors, astronomy, display technology, telecommunications, and defense. Southampton's MSc in Optical Engineering is based at the Optoelectronics Research Center and focuses on lasers, optical fibers, waveguides, communications, computing, and sensors. And that tells you the global market for optical engineering is broad, deep, and technologically central. So now let us make the job feel real. An optical engineer does not just study light, they solve problems using light. They may design a lens system for a camera, improve a laser path for manufacturing, reduce optical loss in a fiber system, model how light behaves in an integrated photonic chip, build a sensor for a medical device, choose coatings to reduce reflection, or align components in a precision instrument. Edwin Optics says optical engineers design optical and optomechanical systems from components to assemblies, including imaging and laser optics, and they are deeply involved in tolerancing and complex optical and mechanical analysis. FISBA adds that optical engineers work with lenses, lasers, mirrors, LEDs, microscopes, displays, photodetectors, computers, and specialized software in fields such as medicine and manufacturing. So imagine a normal working day. In the morning, you may simulate a lens system in design software. After that, you may sit with a mechanical engineer to discuss packaging, alignment, or tolerance issues. Later, you may test how a prototype performs in the lab and compare measured results with the model. On some days, you may work on optical communications. On other days, you may work on biomedical imaging, spectroscopy, sensors, or photonic chips. At more advanced level, you may move into R&D, product development, systems engineering, or interdisciplinary research. Now, this is one of the reasons I find this career exciting for Gen Z. It gives you the joy of physics, the problem solving of engineering, and the visible impact of product development. You're not only learning equations, you're helping devices see better, measure better, communicate faster, and detect more accurately. To become an optical engineer, you need a strong quantitative foundation. Physics is the heartbeat, mathematics is the language, and engineering is the structure. You should be comfortable with optics, waves, electromagnetics, materials, electronics basics, and computation. And beyond that, you need design thinking, problem solving, precision, patience, and the ability to work with both theory and hardware. Creole's undergrad program says students learn to analyze and design optical and laser systems for manufacturing, healthcare, telecom, defense, security, and entertainment. The University of Arizona says its program spans optical engineering, optical physics, photonics, and image science. Southampton's optical engineering degree emphasizes communications, computing, sensors, lasers, fibers, and waveguides. In practical terms, software skills matters too. Many optical engineers use simulation and design tools, and IIT Delhi's photonics lab mentions software such as numerical, OptSim, and network analysis tools for student training. Coding in Python or MATLAB can also help, especially in modeling, automation, and data analysis. And for Indian students, a sensible route is usually this: take PCM in class 11th and 12th, then move into BTech in electrical engineering, electronics, engineering physics, instrumentation, or allied branches, or into BSc BS physics if you want a more research heavy path. After that, specialize through optics, photonics, optoelectronics, or optical communication at the postgraduate level. IIT Delhi's Optoelectronics and Optical Communication program is one strong option. IIT Delhi's Optics and Photonics Center, IIT Madras's Photonics Ecosystem, and IISc's Integrated Photonics and Research Pathways are all excellent Indian launchpads. And if you want the best known universities abroad specifically for this area, then a short list would include University of Rochester, University of Arizona, Creole at the University of Central Florida, and University of Southampton. Rochester is historically one of the biggest names in optics education. Arizona is a world-class optics and photonics hub. Creole is highly respected for both research and applications, and Southampton is especially strong in optical engineering, optical fibers, and photonics. And now let us come to the most sought after question. Yes, salary. In India, Glassdoor reports the average salary for an optical engineer at about 8.61 lakhs per year, with a typical range of roughly 6.2 to 14.7 lakhs, and the top reported earners around 19 lakhs. For optical design engineers, Glassdoor reports an average near 7.2 lakhs per year, with the common range lower than the broader optical engineer category. Now, these are reported salary estimates, so actual pay depends on city, employer, product complexity, and whether the role is R&D heavy, manufacturing linked, or more junior in nature. Abroad, the numbers can be significantly higher. The United States, Glassdoor reports an average optical engineer salary around $150,000 per year, while ONET's wage data for photonics engineers shows a 2024 median of around $117,000 annually. In the UK, Glassdoor reports an average optical engineer salary of about £39,000 per year. In Germany, Glassdoor reports around 72,000 euros per year as an average. Now, these figures should be treated as broad benchmarks, but they clearly show that this is a technically valuable and well-paid field in advanced optics markets. So yes, this career can be financially rewarding, but it pays best to those who build real depth: optical design, photonics, systems understanding, simulation ability, and strong interdisciplinary thinking. So, what should you remember from today's episode? An optical engineer is someone who makes light useful. That sounds simple, but it covers some of the most powerful technologies shaping modern life: imaging, lasers, telecom, semiconductor tools, biomedical systems, sensors, satellites, machine vision, AR, VR, and photonic chips. In India, the ecosystem is becoming stronger through institutions like IIT Delhi, IIT Madras, and IIScs, along with growing research and manufacturing relevance in photonics. Globally, dedicated centers like Rochester, Arizona, Creole, and Southampton show just how important and future-ready this field really is. So, if you're a student who loves physics, enjoys precision, and wants to create technology rather than only consume it, then optical engineering may be one of the smartest careers you can explore. It is a field for the student who looks at a camera and wonders how it sees, who looks at a laser and wonders how it stays so exact, and who looks at a fiber cable and wonders how light can carry the world's conversations. That curiosity is not random, it may be a career signal. And now, let me speak directly to the student or parent listening to this episode. If today's episode on optical engineering opened your mind to a career you had never seriously considered before, just imagine how many more right fit careers may still be hidden from you. The right career is not found through guesswork, pressure, or random opinions. It's found through clarity. If you're confused about your career path, subject choices, college roadmap, or future direction, connect with me for my career counseling program. I help students understand their strengths, identify careers that truly fit them, and move forward with confidence. Whether you're interested in engineering, science, research, study abroad, or a niche future ready path like optical engineering, I can help you decode what is right for you. So do not leave your future to confusion. Message me today and let us find the career path that is truly meant for you. Your dream career was never lost, it was simply unread. So let us decode it together.